Okay, we'll just get started then. So my name is Nick. I'm the Scientific Sports Specialist with ADInstruments. And today we're going to cover custom calculations in LabChart Lightning. So this is, we're using this basically to look into how we can tailor this to your data sets and what it is, how we can import calculations, export calculations. And there are definitely similarities to calculations that you see in LabChart 8, but there are also quite a few differences, and we're going to explore that today. Just minimize that. Okay, so to explain this, the best way would be to go through some data sets. So I'll go through a few types of data sets here, and also examples of when to use custom calculations. So if you're not familiar with Lightning at all, I do have some past webinars on this, and please email me and I can forward you those. But if you are familiar with this, then it may look quite different from what you're used to. This dark theme here. But if you like to, you can always go to View and modify this to light theme if you prefer. We'll just go back to dark theme. So what custom calculations are is just basically you're looking into simple things that can be anything very, very simple as the cyclic measurements or your derivatives or integrations to something that's far more complicated that you use within arithmetic if you use that in LabChart 8 or 7. So to start this, what you see here is just a basic data set showing a lead 1 and lead 2 of an ECG. And my objective here is to do some calculations to calculate lead 3, lead AVR, lead AVF, and lead AVL. So these are primarily used in cardiac access when you are looking into the pathology of the heart, specifically the electrical activity, the vectors, so which direction the activity is going. And by telling us the direction, then we know how the heart's behaving, if it's behaving correctly, or if there's some abnormality like hypertrophy. So to start this, what you see, first thing you can see, we have 3 channels here, and we have some leads. So there's 2 signals. First step is just to click on here, and then the first step is to go to Add Calculated Signal. If you're not familiar with this box at all, it's quite similar to what we see with LabChart 8. Our sampling is just pretty much used for signal conditioning, and our units is used for units conversion. And the readouts just show you a DVM, which is similar to the readout you see with LabChart 8. And of course, I can also remove the signal as well. For basic calculations, we'll go here, Add Calculated Signal. So I'll review what this is here, and then I'm going to do some basic calculations, and then we'll move on to custom calculations so we can review everything. So what you see now is I have no calculations at the moment. As you can see, no calculation. And on the right here, we have a little preview window. If I use my scroll wheel, and if you're using a laptop, you can use your trackpad. You could basically zoom in and out just like that. Same thing on the scale. I could modify this on my scroll wheel or trackpad. You can see we have an input of lead 1, which is colored in red, and we have an output here in green. So the advantage here with using color coordination then just makes things a bit easier to understand. As we don't have any calculations, which will, once we actually drop a calculation, it'll be in between the input and the output. But of course, as there's nothing here, if you can see, if you notice carefully, we have 2 signals here, so they're just superimposed on top of each other. But once I add a calculation, that's going to change. Options here, I'll talk about this quite briefly, but if I do click on my lead, this is my input, I can modify this to another signal. So just because I click on lead 1 doesn't mean it has to be lead 1. I could actually modify this to show lead 2. The other examples here are calculations that I've done in the past, but the smart thing that Lightning does is that it remembers all of your calculations that you've done. So this is to do with the history that it has. So that way, any sort of calculations or any modifications you make or channels you create, you can always go back and see them in a case like this. But to make things simple, I'm just going to keep that as lead 1. And we have an I here. So this I simply can hide my signal. So this is used, it's quite simple at the moment, but when we do some more advanced calculations, then it becomes really apparent how important these are. So if I just hide this, you can see it just shows my first input only. Alternatively, you know, if I hide that, it's just going to show green, but that's fine. But that's what the eye does. If I go here, you'll see some of the usual suspects when it comes to calculations. So you can see this also in LabChart 8. You have your differentiations, so you can do your first order up to your fifth order. You have your integrals, you know, so these are quite handy when you're looking into spirometry or looking into volume, etc. The filters here, really important when you're looking into things that have noise, high frequencies, or maybe you have some drift. That's when you can use your filters as well. If you're looking at a specific frequency, then we can use these, of course. Shifting just is able to shift your data if you need to. Smoothing is really handy. If you have quite a noisy signal, which this one has here, I can apply a smoothing calculation just to smooth things out a little by just using either a triangular smoothing technique or a mean smoothing or median smoothing or a Svatsky-Golay smoothing calculation. And the cyclic measurements are pretty common among people that they use when they are doing calculations. So that's just to do with, you know, rates, frequencies, means, mins, maxes, you know, mean arterial pressures, etc. So it's a really important tool to use. And the save calculations is an option there that I'll show you that once you create your own calculation, then you can save it, and in this way you can see it here. So this we'll talk about a little bit later on in the webinar. But now just to review some basic calculations here. So if I, for example, I notice that this one's a little bit noisy. If I apply a smoothing, a Svatsky-Golay, now you can see a window's popped up in between, or a box has popped up between my input and my output. So first you can see a polynomial degree and the window width. So what the smoothing technique does, it applies a polynomial degree with a certain window width, like a certain window width box, around each sample point using the least squares fitting. And this way it's able to estimate mathematically a nice smooth calculation. So what if I do here, if I modify this to, let's just say 15, what you see now is that I modified the window width to be 15, is you can see my input is red, but my green is my output. So that shows how I've smoothed this calculation. And if I add calculation, you'll see now that even though it was green before then, it sometimes changes color here. So don't worry about that. You can always just modify the color here at any time. But you can see now I have a calculation right here showing me the smoothing of my original signal. And one of the advantages here, of course, with LabChart Lightning is that I have the ability to superimpose these onto other signals, or I can just drop them down really effortlessly at any time that I like. Of course, I can just put this back up here, just like that. And if I want to go back to that calculation, I can just simply click on it, modify the name if I want to. I can just call it, you know, lead one smoothing. But the important thing here is that it tells you what the calculation is. And if I use these three options here, the properties, so this is pretty common in Lightning. If you do see these three dots, it just means it leads to some other properties. So if I click on here, it goes back to my calculation. Another tip here is the info box. This gives you a very brief overview of what the calculation is and the actual ranges that it has. So you can see here the polynomial degree is from 2 to 6, what it means, the window width, and you know, the data source, and the output is this Svatsky-Golay. And of course, if I modify this, I can show a rate example as well. So if I modify this to, let's just say an ECG human, so this is measuring only the peaks of the R in my ECG. So now you can see if I zoom out, the event markers are only dropping on my R peak, which that will give me my heart rate. So it's a really simple way of having the ability to do your calculations, which, you know, you do have those options in LabChart 8 as well. But what you don't have options in LabChart 8, well, you do, but it's quite limited, is the next step here. So if you go back here, we're going to go to customize. First, we're going to remove this. I'm going to go to customize. So what we see now is an open canvas, and we have our original signal, the input and the output. And of course, now we have a larger preview screen here. So if we can, once again, use my mouse, I can zoom in and zoom out. And we have the overlay here as well. On the right, we have now all of our signals, all of our calculations. So right now, Lightning has quite an extensive array of calculations. So these can be actually divided into events, mathematics, detection, filters, waveforms, variable, cyclic measurements, etc. So anywhere that I click, you'll notice now a box pops up. This is the calculation. So it'll tell you once again what it can do. It'll give you the box and some information on it. You'll notice now it has a source, detection, and peak. So most of these are going to have some sort of a detection setting and also possibly a standard deviation, but not all of them. So some of them may just show something completely different. They may not show anything at all, but it provides a calculation nevertheless. So what I want to do first, the purpose I'm here is to do some calculations to do with cardiac access. Now to perform this, the first step is that I want to calculate lead 3. So I have lead 1 and lead 2, but I want to calculate lead 3. To calculate lead 3, all I have to do is minus lead 2 from lead 1, and that gives me lead 3. So to do that, the first step is I want to be able to move this across so I have room to add some calculations here. So anytime I see the forward arrows, I'm going to left click down and bring this across like that. And you'll see a line is just connecting these two. So this tells me that this is the connection that is, that's going to, but I have no calculation at the moment. But now all I have to do is I want to minus these. So if I search up here, I can either go to my functions and find the function this way, or I can go all functions and just type in minus like that. Now you'll see if I click on here, the minus pops up. If I left click and bring this in, it'll go into the canvas. Alternatively, I can left click up here and bring it in, either way. The important thing is to put it in the middle of the signals until you see that plus. You see that plus? And then you release left click, and now it's connected. So you can see now lead 1 is in X minus 0, which is Y, and that gives me this. And of course, as it's just 0, the signal looks exactly the same. No, there's nothing different. But now what we want to do is we want to introduce lead 2. So to do this, down here we have our input, parameter, and output. I'll talk about the input and output now, but the parameter we'll talk about a little later on. With input signal, we're going to left click and bring this in. And of course, this is lead 1 showing at the moment. But what we can do is if we left click on this, we can go to lead 2, like that. So now you see 2 signals are going. We have lead 1, we have lead 1, but we have lead 2. But we want to minus lead 2 minus lead 1. So to do that, the first step is I want to move this signal down to the Y notch like that. And I want to move this left click and bring it in like that. So we just click from here and we bring it to the notch. And now I can just make this a bit simpler to see like that. And just bring that in. You can just modify this whatever you like. We have the mouse wheel as well, or the trackpad. You can zoom in and out depending how large the calculation is. But otherwise, you can see here, it simply is lead 2 minus lead 1 equals the output. And you can see there are 3 signals here. So that gives me the 3 colors. But if I want to, I can just use the eye and hide them. And now I only have 1. So we hide this is only done, it's only effective in the actual preview. So, but once you calculate it, all you're going to see is this. So if I go update calculation, and now if I press my order scale, or alternatively, I could double click here and that does the same thing. Now I have 2 signals. I have a lead 1 and now I have a lead 3. And if I modify this to lead 3 by center, that gives me lead 3 now. And if I left click and bring this down, that'll give me lead 3. Okay, now I want to add another channel. So what to do that is I can either right click anywhere on the bottom channel and go to add channel below, or if I want to, I can click on my properties, my show properties for my chart here, and then you can see this window pops up. I can also add here, add new channel. Either way, if I click here, now I have a new channel. So the next one I'm going to do is an AVR. So to do this, I need to simply add lead 1 plus lead 2, and divide it by 2. So once again, we're going to go back to lead 1. I could go to lead 2. It doesn't really matter. I'm just going to go here add calculated signal. Now we can see that we have a different color for this output. Now we're going to go to customize. Once again, we're going to move this down like this, and we're going to go to plus. So plus. So even though I've typed in plus, it still finds something similar, which is of course add. And I can just left click and bring that in like that. And now once again, we're going to bring in the input and change this to lead 2 and connect them. So now that's lead 1 plus lead 2. The next step is then to divide. So if I just divide, here we go, bring that in just like that. And now we've got the divide. So that's it. That's all 3. So now if we update, now we have lead AVR. And we just bring that down like that and modify this to lead AVR. So if I do the other 2 calculations, you'll actually see a difference in actually the signal. They'll actually be inverted, the lead AVL, which is totally normal. Like I said, this is part to do with cardiac access. But the other 2 calculations are pretty much the same thing. So I'm not going to go any further with this particular example as I've achieved it. But that's how we can do simple calculations using custom calculations. So now the next step is I want to talk about doing multiple calculations in the same signal. So let's go to another project. Once again, if you're new with Lightning, what I've done here is that how it works is a project is just a folder. Okay, so if you're familiar with LabChart 8, you would have a folder with all your LabChart files, and that folder is usually called some sort of a theme. You know, some sort of, maybe it's a chapter in your PhD, or maybe some sort of a grant or something like that. This is the preliminary data. So, but within that, the point is all your LabChart files. So projects are simply used as a way to just is the theme of the data sets. And you can see on the right here, I have 4 different recordings. This is 4 separate LabChart files, and I can actually open up any of these in LabChart 8 if I wanted to, or LabChart 7, I can do that. But this way, it's just a very simple way for me going from one file to the other seamlessly. And this is when it's really important when you want to do cross-file analysis, which I did mention, or which I did do in a previous webinar. But what I'm going to do is move on to another project. So if I go to recent projects, let's move to demo project. And we'll move to BP demo. So this demo here shows me a ventricular pressure and arterial pressure of a rat. And what I want to do, I want to apply some derivatives, and also want to do a cyclic measurement as well. To do this, once again, I'm going to go here, and I'm going to go add calculated signal. Okay, so there's a signal, and there's no calculation at the moment. So to do this, I can either go to differentiate and do it this way. So I could, if you were doing LabChart 8, if you wanted to work out, let's just say your first order, then your second order derivative, and then you want to work your heart rate, you would need 3 separate channels to do this. Alternatively, you could do it under arithmetic in LabChart, which will then put it into one single channel. But doing that will be a fairly complicated, calculation you need to do. But Lightning provides a very simple way to do this, and we'll demonstrate that now. So the key here is I'm going to go to customize, and once again, it's going to bring that out. And the first step is to look for differentiation. So I'm just going to go differentiation. Here we go, differentiate. Left click and bring that in like that. So now you can see I have a differentiate. This shows me my window width. So window width is just used to average points between each sample, and the higher the window width, the smoother this is going to be. So if I modify this to, let's just say 9, you can see now the signal is smoother. If I make this too large though, the signal is going to be biased. It's just going to ruin the signal. So you want to make something that is not too low, but not too high. So 9 looks about right. Order is just the order of derivatives. So this is going to be my first order. And the fit order is just a polynomial. So this is a smoothing ability that you can do. So how many polynomials you want per sample. So if you want some extra ability to smooth, you can do that as well. But most of the time, if you've got the window width right, you don't need to modify this. So you can see here, that's my first order derivative. And you can clearly see this shows me the peak is my maximum slope, and then the trough is my minimum slope right there. So that's one. So let's do the second order derivative. To do that, once again, we're going to left click here and bring this out. And we're going to left click up here because we're still using the same input and bring it out like that. Now we're going to go here and click output signal here like that. But now what we're going to do, we're going to modify this to 2, second order derivative, and then connect these like that. And this is quite messy at the moment, but to modify that, all I need to do really is modify my window width. Remember, window width helps you just smooth out your data, but you can also use the field order. And you can see here that the second order derivative is the derivative of the first derivative, and you can clearly see there, this is with respect to time. You know, this how you can define the second order derivative. And you can see there that the peak of the second order derivative is when this starts to rise, and then when the derivative here it starts to plateau, and then it drops when the time point when the pressure starts to fall here. So that's 2 calculations there. But now I want to apply a cyclic measurement as well. So I want to measure the heart rate. To do that, I'm going to type in CM rate. So if I type in CM rate, there it is. I can left click and bring that out like this. So this one here simply tells me, calculates how often events or cycles of a cyclic waveform repeat. So if I do now the same thing, left click and bring that in, source, and go output signal out like that. Let's just modify this to, yeah, let's just keep it like that for a moment. And what you see, you now have 3 signals, and the event markers are popping at the peaks. If they were not going where you want them to go, or if they're picking up something you don't need, then you don't want, you can always modify the number and make that higher if you want. Otherwise, you can see there are multiple calculations going on like this. So now if I add calculations, what you see, it looks pretty crazy, but there are 3 calculations there. About any time, I can just move these into a separate, you know, I can add another channel. I can add maybe 2 more channels. I can just move these down wherever I like that. And then of course I can just press the auto scale option to scale everything. So you can see how quickly it is to calculate and to provide all this data just from one signal. So this is just, you know, for one thing. So going back to here, going back to my option, it shows me here the calculation. So it says the custom 22, but once you save this under a name, and I'll show you how to do that now or very soon, it can be saved under a name that you want the calculation to be called. But you can see here that that's the input, and these are my outputs. If I go to customize, it shows me my calculation. And if I wanted to, you know, I could bring another input here and modify this to, let's just say, arterial pressure, and then do something with arterial pressure if I wanted to. So you can do multiple calculations this way. You don't have to do them all separate. But here's a perfect example of when you can do multiple calculations at once. So that's the next thing. So the next thing I want to cover in custom calculations was doing calculations on top of another calculations. So this is when we're really using custom calculations. So now let's just go to EEG as an example. Here's a raw EEG signal, and what we see here is I've applied a bandpass filter 4 times for this raw EEG. So what I've done is I've calculated what the alpha wave is, the beta, the gamma, and the theta wave is. So these you can also do this similarly within LabChart 8. So if I click on here and go to here, you'll see my bandpass filter. So I already researched what the bandpass filter is, well, the frequencies are for each particular wave. So for the alpha, it's between 13 and 7, and what you see is here. You know, of course, if I go to my gamma, same thing. You can see there, that's my frequency band that I want, that I'm allowing through. Anything outside of that band is cut out. That's what the bandpass filter is for. But what happens if I want to do something else? So let's just bring this in. like that. Now you can see you can always superimpose something. It's really easy to do with LabChart Lightning. But now I want to apply a qualitative calculation, and this is a root mean squared. So this is pretty common if you're using it for spike histogram, or of course in RMS. I mean, of course in EEG work. So to do this, what I want to do is click on here and go to Add Calculated Signal, and I'm going to go to Customize. Right. So to do this, what we're going to do is we're going to square the signal, and then we're going to use an average seconds calculation, and then we're going to square root it to get our RMS. And what this will simply do, it will just give us peaks and troughs of when the most activity is occurring. So this is once again a qualitative calculation. So to do that, what we're going to do is look for power. Sometimes even if you haven't got the right word you put in, just anything similar to this also works. So if I type in, anything else, sometimes that can work for you as well if you don't know what it is. But otherwise, searching throughout each function for the type of calculation you need also helps. But here I've found power. If I left click and bring that in, now what I'm going to do is I want to square this to the power of 2, like that. And you can see that the signal changed immediately. Now I'm going to look for average seconds. So what this does, this is going to average depending on how many seconds I want, or less than a second. So here I can either do average samples, average seconds. So it gives me plenty of options here when I type in average. But this all I want is average seconds. Bring that in. Now average seconds. Now obviously it's 0 now, so it's not averaging anything. But if I modify this to, let's just say 0.5, now you can see how this looks. So anytime there is a lot of activity in the EEG, you can see the spikes occurring. Or when there's minimal activity, you see it fall. And now if I just square root this, if I type in SQRT, there's square root, left click and bring that in. So that just square roots it. So now you can see that I've compounded my calculations on top of each other. And this is when it's really simple to use custom calculations in LabChart Lightning. You can do this in LabChart 8, but the formula, you have to research it. It's easy to make a mistake, and it's hard to follow if you're not following the correct steps. In LabChart Lightning, it's a lot simpler to do. So this way you can see the amount of combinations here are, I can't even compute how many combinations there are, but just any type of function you have, you can just simply calculate one calculation on top of another, on top of another, on top of another. Just keep going to get what you're looking for. So that's the power of custom calculations, and that's what I really wanted to get that point across to you. So now if I add that calculation and now move this across down here, let's call this RMS. Like that. If I just zoom in here, you can see there's my calculation. So anytime you see this extra activity, you can see that now in my RMS calculation. So that's how we can do a basic calculation like that. So now if we go back to our customize, you notice it's called custom 25, but now let's save this to our library. So if we go to customize, there's our calculation. Excuse the red line here. What we can do, if we go to save a copy to function library, we can save this as, let's just say RMS, and we can give it a description if we want. So root mean square, save to library, update calculation. So now if I go back to here, and if I go under here, so we have our basic calculations, but if I go to save calculations, there it is. So now the calculation saved. Now, of course, if I also go to my customize, if I look here as well, type in RMS, RMS is there as well. So that's a really easy way to do it. Now, me saving a calculation is only going to save within the project. So that means, so if I just update this calculation, now if I go to obviously a different recording, let's just say ECG, you can't do it, you're not doing RMS for an ECG, but I'm just showing it as an example. Here, the RMS is still there. but that does not, it's not there if it's a separate project. So if I go to another project, just an example here, and go to add calculation, and then look for save calculations, it's not there. It's only within certain projects, but there is a way to fix this. To do this, we're going to go back to our the project, demo project, and now what we're going to do, I'm going to go back to EEG, going to go here, and now what we're going to do, we're going to customize, but we're going to choose something called export calculation. Once we export a calculation, we're going to call this RMS and give it whatever description you want. Now, if I click export, I can now export it to my desktop and save. It tells me there it's exported. Continue. Great. Update calculation. So now, if I go to a separate project, so let's just go to custom calculations project. Actually, we'll go to NIC calculations. Yeah, I want to do an RMS for this spike histogram example. To do that, I'm going to go to File, and I'm going to go to Import. So here, you can import projects. We can import recordings, so LabChart files are your recordings, or we can import calculations. To do that, we're just going to go to Import Calculation. And there it is on my desktop. If I double click on that, boom, imported right there. Now I can do the same thing. If I go to here, add calculation, then I can go to save calculations, and RMS is there. And that'll provide me my RMS, just like that. Maybe I just modify this to make this a bit easier to see. I can just move this down. I can zoom in a little, and it shows me my RMS for this particular signal. So that's how you can, so the way we can do it, how simple this is that I can provide a calculation, I can save it, I can send it to you, and then you can apply it to your data. So that way, it's a really simple way to do this. The custom calculations feature, it is in many ways replacing quite a few parts of modules within LabChart 8. And this way we can give the user more freedom and flexibility to create their own calculation and then have the ability to send it to their colleagues, and then they can critique it and how it works. And because we want to just break those shackles of sometimes the modules that maybe they're too strict for what they can actually provide you, and then we want some more. The custom calculations feature can provide that, and this is something that we're constantly updating and improving, in our research here. So let's just go back to our other project here, the demo project, and I want to talk more about this now. Let's now go back to this. Now you notice here that when I've saved this, I have not. It's just giving me a custom 25. It's not giving me any options here. I can't actually do anything. So what I mean by that is, if I go back to my recording, my NIC calculations recording, what you'll notice is, remember that when I did the calculation, there was, I squared it, average seconds, and I square rooted it. But if I save that calculation and I send it to you, if I go to customize, all you're going to see now is one box. You're not going to see the calculation itself. And I can't actually modify anything. So if I wanted to modify, let's just say, the average seconds, I can't do that. But now let's show you how you can do that. To do that, what you want to do is go back to the original calculation. And the important thing is to choose something called parameter. This is a really important feature. What we want to do is the parameter will basically take over any value that's within a calculation. So you can see here it's 0.5. If I bring it in like this, now the 0.5 is here. If I save this, just say update calculation, what you'll notice is when I go back to my calculation, now we have 0.5. What that means is if I save this now and send this to my colleague, they'll have the same as long as I have the parameter there, they'll have the same option there that they can modify this for what they want. So if they wanted to, they can modify this to, let's just say 0.1. Maybe that was a better fit for their data, or maybe 1 second was a better fit for their data, they can do that then by simply adding the parameter. So the parameter is a really important feature that I would recommend you use. So anytime, like I said, you see this notch, you can add a parameter. Same thing here. I mean, I'm only going to square this, so I don't need to add it here, but if I wanted to, for the sake of argument, I could just add it there, and it's going to add a parameter. So that way, if I update my calculation and go back to it, you'll see now I have 2 parameters, and I can modify that whenever I like. So that's a really handy thing to have with your custom calculations feature. So the next thing I wanted to show was, let's go into something a bit more advanced. Okay. So now we're going to look at something called conduction velocity. So what we're seeing here is we're seeing one action potential, but we have we're detecting the proximal and the distal nerve action potential. So we're stimulating a nerve. We're seeing the action potential of the proximal side and then the distal side. So you can see there the distal is in blue and the proximal is in red. And if I zoom out a little and zoom out a little like this, you can see, if I zoom out, you can see these peaks that are occurring. So the custom calculation that I've done here is that I have done a simple calculation to work out the time between the peaks here and here. And you can see it in green, is 0.0004 seconds. So how did I do this? We're going to go to the calculation here, and we're going to go to customize. So this is a little bit more complicated, but we'll go through it together, and it's fairly simple. And the principle here is we can use to apply this to other calculations that I'll also show you. So when you do your calculations like this that seem maybe a little bit complicated, the best thing to do is use the output signal. The key with the output signal is to connect it to any calculation you want. So let's just say, for example, here, what I've done first is I've added my proximal and my distal here. So if I click here and bring it together, what you're going to see now is the solution to this is yellow. You can see it there. I can hide these. Remember, you can hide these. This is the advantage of hiding colors sometimes, just to make things a bit clearer and a bit more simplistic, because it'll get too chaotic if there's just too many signals just going across the preview screen. The next step is to do a CM period. The CM period calculates the intervals between the occurrences of 2 events in a cyclic waveform. So you can see here, these are my 2 events, the peaks. So what am I doing here? Once again, if I use output signal, bring it out, drag it out like this, it's showing me now the time between my events. So it's showing you here 0.004 seconds, but then it's also showing you pink some other times. And these times are the times to the other peaks. So you can see here, it's 0.09. We're talking about really small times here. I mean, once you stimulate the nerve, boom, it's like that, super quick. You can see there, just these are the time points of the events, time points of the next event. But what we're concerned about is just this event. We only want to know this one. We don't want to see this. So what do? We use a really important calculation. It's called greater than or equal to. So this one here, it tells us, I'll keep this as simple as I can, if X is greater than or equal to Y, then we give a 1. We give a value of 1. So we multiply the values by 1. Otherwise, it returns a 0. So what that means is you can see here, my X is 0.006, right? My value down here is 0.0004 seconds, okay? So this is obviously lower than 0.006. So since X is greater, remember, since X is greater than Y, so since this is greater than Y, which is here, then it's going to be, gives me a return of value of 1. But these values here are higher than 0.006, okay? So that's why they're giving me a value of 0. And I can confirm this once again by using the output and bring it out like this. You can see that now it's showing me that my value is 1 when it's below 0.006. But at these values above the X, then they're giving me a value of 0. So now if I just remove these now, and just show you these again, If I divide then the value, so anything that's multiplied by 1 will be itself, but anything by 0, it will be 0. Then we multiply that by the original calculation, the CM period, and now it gives me the calculation here. So that's how we can do it. So by using that advantage of using the greater than or equal to, I'm able to differentiate or discriminate specific signals just to show this one here. And now I can save that, I can export it, and I can send it to someone else that's also doing conduction velocity. So that sort of a principle I've applied to another calculation. So if I go now to File, Net Calculations, I've done the same thing with my, here we go. So this is an example of, if I just blow this up, make this a bit bigger. This is secure, here we go. I think we got a chat comment. Will we get the recording? Oh yes, you'll get the recording, no worries. Here's an example of an ECG. And now we have the same sort of a line. This is calculating the periods between the R peak and the T peak. And once again, I've calculated this myself. Go here. You can see I've created some parameters here. I'm going to customize, and now I've done the same thing. So I've done a CM period, but I have done my input. This doesn't have to be here. I can just remove that. So you can just see there's my standard deviation. So once again, something simple. If I show you here, I've done a CM period. So that's showing me my period from this calculation here. This period shows me my events. You can see here the events are popping up. So the events are only showing on the R and the T wave because my standard deviation allows this. If I modify my standard deviation, it's only going to show my R wave. So it's going to make sure you have the correct type of standard deviation to show what you want. Okay, so you can see here my periods. But you can clearly see here that these periods are definitely shorter than the long ones. So all I've simply done was I've done the same principle. I've done a greater than or equal to once again. So that way, if I show you here, anything that is above 0.5 is removed. So if I just hide this and hide that, anything above 0.5, well, let me show that, is removed, but anything below 0.5 is, because these periods are all below 0.5, that's why they're 1. That way, since they're multiplied by 1, they're themselves, and then I just multiply, then I divide it by the CM period, and now I get my original signal, which you can see right here. So something simple as that, I can then apply to my data set. I'm just going to remove this one. So that's just a simple principle of what we can do. I'm using the greater than or equal to. So these sorts of things can be applied to all types of calculations. Once again, if we go back to my my calculations here, it's just a matter of having a play with it and playing with the data and seeing what you see here. Because I can spend all day on this, just going through the different types of calculations we have and what are their effects, on your work. So you can use these, of course, if you're looking at blood pressure, possibly some work within spirometry, you can use it in EEG, of course, some neurophysiology is possible. But otherwise, if you have any questions, please ask me, and we can just go through these together. Absolutely. So please have a go with LabChart Lightning. So if you are interested, just bring this in here. That's our website, LabChart Lightning. You can see this on the ADInstruments website. If you go to ADInstruments/products/LabChart/Lightning, you can grab a free trial for 30 days, and you can install it and just try it out to see if you have, LabChart files. You can put it on. If you have a Mac, LabChart 8 Mac will be fine. But if you're using LabChart Mac for 7, then you'll have to convert to Windows format, and then that'll open up then within Lightning. And here just goes through, you can sign it up. Here's some stories about people that do use Lightning at the moment. We show some feature comparisons between Lightning and LabChart 8, and just the basic, overview of what Lightning has for you, what it can achieve. So this is all of our team is focused on this. We're growing on this product, and we'd love to get more people involved with it, get their ideas, get their initiatives, what they want to see, and I'm more than happy to help you all out with it. So thank you very much for joining. Are there any other comments? Otherwise, I will end the webinar, but like I said, I will send you all the recording and answer any questions for you, or forward you to our sales team as well. Also, if you do have LabChart 8 Pro, you're entitled, at this moment, you're entitled to 1 year free subscription to LabChart Lightning. So that's really handy to have. So is there any questions at all? So yeah, like I said, it is somewhat similar to arithmetic if you use that in LabChart 8, but this is a more simplified version. It's easier to use than just using arithmetic. Okay, well, if that's all it is, thank you very much for attending. I'm now going to close off this webinar, but I will be continuing on this series, but I've now finished all the content for LabChart Lightning, but I'll be moving back to LabChart 8. So the key there is just to go through all the modules, going to go through every type of, stimulator, all types of things. I'm just going to go through that. Got one more comment here. For LabChart 8 Pro, will it work on Mac or Windows only? LabChart 8 Pro will work on both platforms, 8 or Windows. Shouldn't be a problem at all. And the other thing I did want to talk about last is that this, even though I've demonstrated on Windows, it works exactly the same as Mac. So you can install it on Windows and Mac. LabChart Lightning will work identically. And I'll send out the recording, it's not a problem at all. So thank you very much. It was a pleasure doing these, and I look forward to seeing you next time. Thank you.